Okay, well, one last centripetal force application. This one is actually, I'm not going to do the math on this one. The math will take me a long time, get involved, and I figured I could do math, not do math. I'll just do the theory behind it. It's a banked turn. If you ever watch NASCAR, you see them going around these banked curves, right? They go around these banked curves that are angled, and that obviously must help them go around the corner. Well, how does that make them go around the corner? So let's say that you are looking at a cross section of a banked curve. So here comes the car coming down the track, and it goes into this turn. So it's going into the board. So we'd be looking at the car from behind it. That's behind the car. And there's a license plate so you can see the back of the car. So it's going into the board. The car's going into the board like this. And the Jolly Green Giant, Green Giant, has come along and gone thwack and chopped that road so you can see a cross section of it. If we do a little bit of triangle stuff, I know, triangles. If we do some triangle stuff, but actually before we do the triangle stuff, I just want to show you that there would be a weight vector going down. Weight goes down, straight down, and for every action, equal opposite reaction. So the car is pushing on the road, and the road would, Newton's third law, that's correct, push back on the car. So the road would push back on the car with equal amounts of force. Now the interesting about this is, usually we're interested in drawing a triangle, looks like this, with inclined planes. Not this time, because that's the triangle we want to use going up and down the inclined plane. We're not going up and down the inclined plane. We're going into the board. We're going across the inclined plane. That's not the triangle we're interested in. This time we're interested in a triangle that's constructed from this upwards force. You push on me, I push on you. But that push back has two components. Okay? Mr. Krabs, you're in the way. You gotta move. Come on, buddy. There we go. Okay. That upwards component, the upwards force, reaction, and force, reforce, has two components. Remember, any vector can be broken down into two components that make a right triangle. And this triangle has a component that pushes to the left, everything you own in a push to the left. I should write music, I got some great lyrics. This is the one that we're interested in. Why? It's pushing toward the center of the circle. Think about where the center of the curve is. So here's the curve. The curve center is over this way somewhere. It's over this way. As we go into that turn, that curve is to the left over here somewhere, and that arrow is pointing in that direction. A force vector pointing in the direction toward the center of the circle is by definition a centripetal force. Therefore, sorry, I didn't mean to get so wavy at you. Therefore, that arrow right there, pointing toward the center of the curve, is a centripetal force. In other words, a banked curve pushes you toward the center of the curve, giving you a boost to go around that curve. So you get help not only from the friction between the tires and the road, but you also get help from the push to the middle. And that all I got to say about that.